Saw a Numberphile video today where the question was, what is a number? And their answer was, whatever the fuck you want it to be. Not even kidding. That was their answer. They started off with, I don't know, and they ended up with, sure, it's whatever you want. No. One of the problems is the question is not really asked intelligently. Right, so you're asking, what makes 7 and -4 and I numbers? Those aren't all numbers. That's the problem. That's why you can't answer this question. You can't come to an answer to this question because the question that you're asking is fucking nonsense. Okay, so the difference between 7 and -7 is direction. So the negative is actually a unit. It's not part of the number at all. It's like saying one hamster is different from one dog. Those are different ones. That's what you're saying. When you're saying that 1 and -1 are different. They're not. They have different units. 1 may not have a unit at all, or its unit may be positive. -1 definitely has a unit, and the unit is negativity. It's whatever your default direction is, we're going in the opposite direction. And we're going 1. Right? The magnitude is the number component of this. And the same thing applies for I, the square root of -1. Right? The difference between 2, -2, and 2i is just the directions that they go in. That's it. So the thing that you're looking at that's making them different is not any number quality. It's just the direction that it's facing in 3 space. That's not part of the number. Right? Because, say I take a ruler or something, right? That's 1 foot long. It doesn't matter how I orient it, it's always a foot long. Its length is always the same. That number represents the length, right? It doesn't matter how I orient it, it's the same. It's always the same. It's the same number, right? It's the same 1 foot. Right? And if it were a centimeter, so there you go, we changed the unit, right? So now it could be 1 centimeter in any direction, or 1 whatever in any direction. It doesn't matter. We don't have the idea that the foot or the centimeter component of it is part of the number, or the direction. The direction it's facing is not part of the number either. But in mathematics, the direction is part of the number. What? The fuck? No. If we were strict about it, +3 and 3 would be different things. We would notate them differently. We don't notate them differently because the people who set up our method of doing mathematics didn't understand what they were doing here. They just didn't, right? 17 and +17 are different things, right? 17 ducks and $17 of debt. Well, now they're in different directions, right? 17 ducks is positive, isn't it? $17 of debt is negative, probably. But it's still 17, right? So the unit and the direction aren't part of the number. So if we're honest, numbers are from 0 to infinity, doesn't include the negatives, doesn't include the imaginaries, or the complex, or those aren't numbers. Those are things that it's kind of like definitions in a dictionary when you got like 7 different definitions for one word, but it's all pretty obviously, there's a core meaning that comes through all of them. What has happened here is extra context has been tacked onto the claimed meaning. It's not that extra context isn't really part of the meaning. That's what's happening here with numbers. And it's why the whole conception is garbage, because it's wrong. It doesn't work. Right? -4 is not a number. 14 plus 3i is not a number. We call it a complex number. Conventionally, it's considered a complex number. That's not a number, though. It's a vector, which is different from a number, right? Because the vector has magnitude and direction. All of these things, like the positives and the negatives and the imaginaries, and we can extend that, right, to like the quaternions and whatever. Those are vectors, not numbers. And you can say, well, vectors are numbers, but you're wrong. You're wrong, because 7i and 7 and -7 all have the 7 component shared between them for a reason. That's the number. That's the number of i's that you have. That's the number of negatives that you have. That's the number of positives that you have. That's how far you are away from the origin. That's the number part, the magnitude, and only the magnitude. The rest of it, the direction, is not part of the number. Right? So this whole, like, integers, it's not a set of numbers because it has the negatives. It's a set of vectors. Right? And the rationals, so it's construed incorrectly, right? The natural numbers are, as are noted in the video where it starts with 0, are really the only numbers. Right? Like, except no, there's a problem, because we don't have the fractions and the irrational. They're not there, but they're not going to be positives. They look, the way we talk about it, they look like they're positives. But like the square root of 2, it's not positive. It's just the square root of 2. It doesn't have a sign until we turn it into a vector, and now it's not a number anymore. So there's a fundamental problem here. Square root of 2 and the positive square root of 2 are different from each other. So the mathematical set of the rationals, which has the square root of 2 in it, but also the negative square root of 2, these are vectors. They're not numbers. The square root of 2 itself is a number, but the way that it's categorized, by the time we get to it with the rational numbers, we're already looking at vectors anyway. So that's not a number. The square root of 2 that's a rational number is not actually a number, it's a vector. Right? So you have to clean up all of this shit before you can even ask what is a number, but it doesn't occur to anybody to clean this up. We'll just casually accept that vectors are numbers. And now, if you are accepting that vectors are numbers, it makes perfect sense to use set theory, because what we're doing to get all of these different kinds of vectors is we're adding all sorts of semantic content, which is just elaborating on the set specification. That's why set theory works for this so well, because that's literally what you're doing, right? You're talking about 13 dogs. Right? You're not talking about 13. You're talking about 13 in a positive direction, or 13 in a negative direction, or 13 in the imaginary direction, or whatever. You're not talking about 13. You're talking about 13 somethings. And that is now a category. 13 is not a category. 13 cannot be defined as a set. Not properly. But when we're talking about vectors, you're talking about 13 somethings. You absolutely can define it as a set now. And I find it interesting that this just doesn't appear to have occurred to anybody